Hello everyone. Today I'm gonna discuss the LVM snapshot. What is it, how it works, when you should use it, and when you shouldn't. Okay. Uh, Whether you are a system administrator or a normal user on a personal PC, you have to perform some daily tasks or activities that may eventually leads to change data on your file system. So it's always a good idea to keep a backup copy of the data. But taking a backup every time might not be possible, although backup should always be done on a regular basis to protect against data loss. But what if you want to perform some applications upgrade, which might have a lot of files scattered here and there around the file system, and you need an immediate fix when something goes wrong? So instead of copying all files, which may need huge amount of storage and time, it must be better to use the snapshot instead. The LVM snapshot is not a backup, and it shouldn't be taken like that. But what actually a snapshot is and how it works. The LVM snapshot is everything included on a file system at some specific point of time. It's very much space efficient, which means when we create a snapshot for a logical volume of 100 gigabyte size, for example, the snapshot will take much lesser space. Nearly nothing at the beginning, but as the contents of the source volume start changing, the snapshot size increases accordingly too. So when creating snapshot, it must not be kept for a long time, as it will end up eating all space assigned to it, then becomes corrupted. The case with which backup is the more efficient way for preserving data. The logical volume snapshot uses a copy on write technology that monitors changes to an existing volume's data blocks. So when trying to write to source volume, the block's value first copied to the snapshot, then modified on the source volume. This way, a point-in-time copy of data is preserved on the snapshot till you come and delete it. The snapshot, when initially created, contains only metadata about itself and the source volume data blocks at the instant it is taken. That's why it has a very small size when initially created, and when you access the data of a snapshot, you will see a point-in-time copy of the source logical volume. The snapshot uses copy on write technology to detect when data going to change in the source data block. It copies the value it held when the snapshot was taken to a block in the snapshot volume, then allow the new data to be written in source data block. As more blocks change on source logical volume, the snapshot size grows up accordingly. So when you are sizing snapshot, consider how much data is expected to change on the source logical volume and for how long you plan to keep the snapshot. The amount of space you're going to allocate for snapshot volume can vary depending on the size of the source logical volume, how long you want to keep the snapshot, and the number of data blocks that are expected to change during the snapshot lifetime. As guide, create the snapshot volume with about 10% of the source logical volume size. If you expect that all blocks in the source logical volume will change before removing the snapshot, then the snapshot size you're gonna create should be at least as large as the source logical volume plus some additional space for the metadata. But less space is required if the data changes infrequently or if the expected snapshot lifetime is relatively short. In LVM2, snapshots are read-write by default. When you write data directly to the snapshot, that block is marked in the exception table as being used and never gets copied from the source logical volume. So you can mount the snapshot volume, test your application on it by writing the data directly to the snapshot. When finished, unmount it and remove it. Or as we're gonna do here, we can test the application upgrade on the source volume If everything went well, remove the snapshot and you are done. Otherwise, you can go back to the state when the snapshot have been taken by merging the snapshot with the source volume to get an immediate fix and undoing everything you just did. When you are done with the snapshot, it should be removed from the system. A snapshot eventually fills up completely as more data blocks changes on the source logical volume. When the snapshot is full, it becomes corrupted and cannot be used anymore. Okay, to create and use snapshot, you must have at least one logical volume already configured on your system. Here, I already have one logical volume with name data, and it's mounted on /mount/data dir. You can use the LVS command for checking that. Okay, LVS. And as you see here from the listed attributes, the data logical volume is writable, active, and mounted. Now let's copy some files to this logical volume. You can use the find command to copy some files from /etc/cops to the /mount/data dir. Okay, then before doing anything, let's first list the content of the data volume, which is mounted on the /mount/data dir. Also, you can use the df command to get more information about the space usage on this volume. To create snapshot for the data volume with name snap_data, 10 gigabyte size, which is 10% of the data logical volume size, we use the lv create command with the s option. Here's the L to assign the snapshot size, and small s to create snapshot volume, n to give a name for the snapshot logical volume, and last argument here /dev/myvg/data is the logical volume the snapshot is to be created for. After creating the snapshot, let's now inspect it with the LVS command to see the attributes that are assigned to it. And as you see here, it's active writable snapshot. So you can mount it on some mount point and check its content. And as you see, it contains exactly the same files as that on the source logical volume that we have seen before. It is important to note that if you plan to leave the snapshot for a long time period, keep the snapshot volume size just equal to the size of the source volume you're creating the snapshot for. Otherwise the snapshot get corrupted if the changes on the source volume becomes larger than the snapshot size. Let's now do some activities on the data logical volume, like adding and removing some file from this volume. Now list the content of both volume, the slash mount slash data and the slash mount slash snapshot. And as you see here, the data logical volume have changed to reflect the modification you just did, while the snapshot still keeping the content of the source logical volume at the instant it was taken. Now if you want to revert back your data diary to the state that have been frozen in the snapshot, you first need to unmount both the data and snapshot volumes, then use the LV convert command with the merge option on the snapshot device. And you get back your data diary to the state when the snapshot have been taken, but all files you have added, created or modified after creating the snapshot will be lost. Also, the snapshot volume will automatically be removed after finish up with the merging process. The procedure specified here is much suitable to quickly recover from a bad upgrade of an application. Now, before merging snapshot, make sure that the source volume is not mounted, otherwise the merging process will be postponed until you unmount the source logical volume, and you will instead get the following message when trying to merge the snapshot. Now unmount the /mount/data partition and the merging process starts immediately. Okay, during the merge, if you try to deactivate the source logical volume, you will get the following message telling you that you cannot deactivate the source volume while the merging process in action. But if the source logical volume is in unmounted state, the merging process starts immediately. If you check the logical volume with the LVS command from another terminal, you will see the data volume has an big O attribute assigned to it, which means it is now the origin device with a snapshot do exist. And when done, the data partition restores the state it was on when the snapshot was taken. But what happens if the changes on the origin volume grows up beyond the snapshot size? Here my snapshot volume size is 10 gigabyte, while the data volume size is 100 gigabyte. But as you see, only few megabytes are being used on source logical volume. Let's now create a 10 gigabyte size dummy file in the /mount/data directory. First, we need to create a new snapshot since the old one was automatically removed after being merged with the source volume we previously did. Then create the dummy file. Okay, now check the status of the snapshot volume with the LVS command. And as you see here, the snapshot is now completely full and flagged as an invalid as indicated by the I flag in the attribute column, which means the snapshot is now corrupted and cannot be used anymore. With the LV display command, we have snapshot status inactive destination for data, which means it's not valid. And if you check with the DM setup status, it also says that the snapshot is not valid and should be removed. To prevent the snapshot corruption, we have to extend its size before it becomes fully occupied. We have an option here to automatically extend the snapshot size when its size reaches a specific threshold. To automatically extend the snapshot volume when its size reaches some percentage of its total size, open the lvm.conf file under /etc/lvm dir and change the snapshot auto extend threshold to less than 100%. 70% will be good. Also change the snapshot auto extend percent to the percent value that you want the snapshot to be extended with when the threshold have been reached. And 50% is just nice here. Okay, now create a new snapshot volume with name snap underscore data and 10 gigabyte size for the data volume. Then optionally you can mount the snapshot to some mount point like /mount/snapshot for example. Okay, let's again try to fill up the slash mount slash data directory with some more data that may not exceed the 7 gigabyte threshold barrier. 6 gigabyte will do. You can use the dd command for that. Now check the snapshot volume with the LVS command. And as you see here, everything is good. Since the snapshot size is 10 gigabyte, it can easily able to afford the change without extending its volume size. Okay, next let's add one more dummy file with additional 3 gigabyte to the slash mount slash data dir. Okay, again check the snapshot with the LVS command. And yes, this time the snapshot size increased by 50% of its total size, and becomes 15 gigabyte. This is because we have had asked the LVM to extend the snapshot size by 50% of its total size when the threshold is reached. So this works well, and the snapshot is still valid. But make sure that the source volume never get changed by more than 15 gigabyte, otherwise snapshot again becomes corrupted. Okay, if you like to make an online backup for the data partition, don't merge it with snapshot for now, but just mount the snapshot volume to some mount point like slash mount slash snapshot, then use any backup application, tar for example, to backup the snapshot dir to some archive file, and star command will create a backup file in the current working directory. And after finishing with backup, we have to unmount and remove the snapshot. As you see, this is much more efficient way for online backup. Okay, that's all about. I hope that discussion here helped shed some light on this important topic. Thank you for watching and bye.